Good morning, everyone. Today we are going to be covering topic 1.6, and we're going to be talking about how do we evaluate limits algebraically. So when we evaluate limits algebraically, the first thing that we always want to try is substitution. Always try this first. All right, so we want to try substitution first. But we're going to find out that a lot of times we get something that doesn't work. All right, we might get a situation where we have a 0 in the denominator, like 12 over 0, or we might get an indeterminate form, like 0 over 0. When those things happen, we have to go to plan B, or step 2, which is to try to manipulate or factor. And then evaluate the limit again. All right, so you try to manipulate or factor the expression, then you try to do the limit again. And sometimes even this will fail us, and we will have to resort to the TI-84 or something numerical like a table. All right, so that's kind of our process when we are evaluating limits. You're going to find out some of these are incredibly easy. All right, others require some algebraic work. All right, so let's get to it. Let's say that I was asked to find the limit algebraically here on number 1. The limit as x approaches 4 of plain old 2x minus 3. Now, we know a lot about this function, don't we? Isn't that just a plain old linear? All right, if I were to look at the graph of this thing, this is just a plain old linear, boom, like that. There's nothing wrong with this. There's nothing where there's a hole or something that's undefined. So the only thing that I have to do on this problem is substitute. Plug in the value. 2 times 4 minus 3. And we get 5. So the limit as x approaches 4 of 2x minus 3 equals 5. And we could confirm that in other ways. We could look at the graph. If I were to look at the graph of this thing, and over here's 4, I would find out that the y value that it is approaching is 5. All right. So let's look at number 2. The limit as x approaches 7 of the square root of x plus 2. Now, it might help us to remember what this function looks like. This is a square root function that has been moved to the left 2 units. All right, that's what that looks like. Over here is negative 2. It's been moved to the left 2 units. So if we're doing the limit as x approaches 7, here's 7. We don't have any issues with evaluating this limit algebraically. I can just plug it in. I can do substitution. The square root of 7 plus 2 is the square root of 9. This limit as x approaches 7 is 3. Make sense? But what I wanted to throw at you is, what if we approach a different number with this same function? Like number 3 here. What if we did this same function, but we looked at it as the limit as x approaches -2 from the left? This is why you have to know your functions and you have to know what they're doing. I just told you that this function is moved to the left 2 units and looks like this. So if I am approaching this function from the left, it doesn't exist there. It doesn't exist there. So this limit does not exist. All right, sure, I could plug in -2 and get 0, but if I'm specifically looking at it as the limit as x approaches -2 from the left, it doesn't exist. What if I change this to the limit as x approaches -2 from the right? Can we do that? Yes, we can. Wouldn't this, if I did the limit as x approaches -2 from the right, it would be 0. That's okay. Number 4 always throws people for a loop the first time because I think they're afraid to trust it. My function here is the constant function 12. Well, what does that look like? Here's 12. Here's 12, and we're talking about a constant function that is always 12. This is the easiest problem on the planet, everyone. The limit of this thing is always 12. It's always 12. We like constant functions. We like doing the limit of constant functions because it takes us about 2 seconds to answer them. All right, let's keep going. All right, now we've got something a little bit more messy. Let's see what happens if we follow our little plan about substituting. If I try to substitute, right away, I see a problem. When I plug in 2 here, I'm going to get a 0 in the denominator, aren't I? Now on the top, let's see, what happens on the top? I'm going to have 2 cubed minus 2 times 2 squared. We've got 0 over 0. This is what we call, you need to get it drilled in your brain, an indeterminate form. You even need to know how to spell that thing. All right? That's an indeterminate form. That means we don't know what the limit is right now. And remember, I told you, do not put that this equals this. That's not very friendly for the College Board. They don't like that. You could put little arrows or something. That's an indeterminate form. So I told you if we substitute and we get 0 over 0, or a 0 in the denominator, we need to try to do some factoring. Let's do some factoring. On top, so now let's look at this thing as the limit as x approaches 2 of, on bottom, couldn't I pull out a 3? And make that 3 times the quantity x minus 2. And on top, I could pull out an x squared. And I would be left with an x minus 2. And these go away. And now I can evaluate the limit as x approaches 2 of x squared over 3. Now let's try to substitute. If I substitute now, our hearts are happy because I have 2 squared over 3. That's 4/3. We're okay with that. So when you run into a 0 in the denominator, or when you run into an indeterminate form, factor, then evaluate the limit. All right, let's keep moving here. trying to expose you to some of the tricks of the trade, some of the techniques that you're going to have to run into as we do this. Now, I'm going to save some time here. If I plug in 3, I think you can see 9 minus 3 squared. I'm going to get a 0 in the denominator. On top, 3 squared is 9, plus 12. That's 21. I'm going to get an indeterminate form. So, once again, we don't like indeterminate forms. We've got some factoring to do. On the bottom, I think you can see that is a difference of 2 squares. That will become 3 minus x times 3 plus x. On top, it would factor into x and x, and I believe it's going to be x plus 7 and x minus 3. Now, in case you forgot the little trick that I showed you last year in pre-calculus, do you remember that we can flip this thing by taking out a -1? So I can make this -1 times x minus 3 down here, and that allows me the freedom to slash these two algebraically. And now I have the limit as x approaches 3 of x plus 7 over, this thing went away, 3 plus x. And now we can try substitution. And I have 3 plus 7 over 3 plus 3, which is 10/6, which is 5/3. That's the limit of this messy thing as x approaches 3. All right. Just plugging in 3 after we got our new function. All right. Any questions there? Yeah.
What about the -1?
Oh, thank you. Yeah, I saw some of you looking at me funny. That's my mistake. There should be a -1 here. Thank you. -1. That should be a -6. This should be a -5/3. Thank you. No problem. All right, let's look at this ugly thing. I'm showing you this one. We may or may not go all the way through this one, but I want to show you how to start it and to get rolling on it. Isn't this example 7? Is that right?
Yeah.
Yeah, example 7. So right away, if I plug in -8, I think you see we get a 0 in the denominator. We're going to have to do an algebraic manipulation here. I cannot factor it. There's nothing to factor. So this is where I show you one of the tricks of the trade for factor or cleaning this thing up. Here's the trick. And we actually did this back in pre-calculus. Multiply the top and bottom by x plus 6. What that will do is it will get rid of the complex fraction. When I do x plus 6 times this one, that goes away. And I'm going to be left with x minus, but I also have to distribute it to this 4, x minus 4 times x plus 6. On the bottom, I have x plus 8 times x plus 6. Now, do not make the algebraic mistake of thinking you can cancel these x plus 6's, because I've still got this x minus 4 here. Let's clean it up a little bit more first. On top, this would be x minus 4x minus 6. So on top, I have negative 3x. I'm sorry, when I distribute this 4 through, this should be a 24 here. Negative 4 times x, negative 4 times positive 6. I'm going to have negative 3x minus 24 over x plus 8 times x plus 6. And now on top, I can take out a negative 3, which leaves me with an x plus 8. And now it is okay for me algebraically to slash those x plus 8s. It was not okay up here to slash the x plus 6s because of this x minus 4. And I'm not going to finish this problem because finishing it is easy. You now can do the limit as x approaches negative 8 of our negative 3 over x plus 6. Easy from there. All right. One last thing. This is example number 8. And what we have to use here is the idea of a conjugate. We talked briefly about this last year. If I plug in a 5 here, look, if I plug in a 5, I get a 0 in the denominator. That's bad. I need to do some type of algebraic manipulation. So what I do is I multiply the top and bottom by the square root of x plus 4 plus 3. The square root of x plus 4 plus 3. This is called the conjugate of the square root of x plus 4 minus 3. And the reason it's called the conjugate is because when I multiply this top, I actually have a difference of 2 squares. So on top here, I have this thing minus 3, and I have this thing plus 3. I can do it just like a difference of 2 squares. The square root of x plus 4 times the square root of x plus 4 is x plus 4. Then I can put a minus sign, and 3 times 3 is 9. And look at that. That square root has went away. For the time being, we're going to leave the bottom alone as the square root of x plus 4 plus 3. Just leave that alone for right now. And that is being multiplied, remember, by the x minus 5. All right. And look how conveniently this thing works out. Isn't the top x minus 5? How convenient. The bottom is that ugly conjugate, the square root of x plus 4 plus 3 times x minus 5. And now we can slash the x minus 5s, and we can evaluate our limit. Now I just have the limit as x approaches 5 of 1 over the square root of x plus 4 plus 3. Now I can substitute, and I have 1 over the square root of 5 plus 4 plus 3. The square root of 5 plus 4 is the square root of 9. This is 3. This thing will be 1/6. So now you get to try your hand at evaluating limits algebraically. Remember where we started today. All right, we started with this idea that you always try substitution first. When you try substitution first and you get a 0 in the denominator or an indeterminate form, then you go to manipulate or factor. And I hope that helps you get started on evaluating limits algebraically, and we will stop there.